Welcome to qnawire.
Okay, so in this problem we have unpolarized light passing through an optically active sample between crosses polarizer. So let's simplify. We have the first polarizer here with 0 degrees of the vertical. We have a sample, and here we have a sample, and here the light passes through the first polarizer to the sample and to the final polarizer, which is 90 degrees with the vertical. The final polarizer is a 90 degrees with the vertical. Okay, so the first item of this problem, we need to explain which percentage of the unpolarized incident light will passes through the first polarizer. So just remember that when unpolarized light passes through any type of polarizer, his intensity is decreased by half, which means that only 50% of the incident light will pass through the first filter. So this is the first answer. The second answer is what percentage will passes through the second filter. So again, let's calculate. We know that the final intensity is going to be the original intensity multiplied by the cosine square of the angle, which is 90 degrees. And cosine of 90 is just 0. Therefore, we have a final intensity of 0. So we can conclude that 0% of the incident light will pass through the second filter if there is no sample present. Now, considering this sample, we need to calculate the rotational angle. So we have here an intensity of 0.4 of the original intensity that multiplies, this should be equal the intensity of the first filter, which is y0 divided by 2, cosine square of the angle between the sample and the first filter, which is 90 minus theta. Therefore, we can say that cosine square of 90 minus theta is equal 0.8. So calculating this using the inverse function of the cosine, we have that theta should be equal 90 degrees minus the inverse function of cosine, square root of 0.8. Calculating, we have an angle of 63.4 degrees. That is the rotational angle of the sample in the first filter. Now let's calculate the new intensity. The new intensity is just, let's see, intensity is y0 divided by 2 cosine square of 90 minus 63.4 half. So calculating this, we have a final intensity of 0.138 of the original intensity. And that's the final answer to this problem. Thanks for watching.